In part 1 of lecture 7, we will discuss building the SLR state machine. In the previous lecture, we looked at bottom-up parsing with an LR0 grammar, so we will now try it with our regular expression grammar, which is not as anemic as our LR0 expression grammar. And you can see the productions on the slide. Let's try parsing it as we did in last week's case. We will parse the expression x plus y times z. Our first token is identifier, which we will push on the stack. When we see the plus sign that comes afterward, we will reduce by production 5. Factor derives identifier. We pop the identifier and replace it with factor. We then reduce by production 4. Term derives factor. Popping the factor and pushing on a term. We reduce by production 2 now. E derives t, popping the term and pushing the expression. We will then shift past the plus sign, pushing it on the stack, and do the same for identifier. We reduce by production 5, replacing identifier with factor, and then reduce again, replacing factor with the term. And then what? We have a choice. We can either reduce by E derives E plus T, or we can shift, placing the asterisk on the stack. But the problem is that without looking at a look-ahead, we can't say for sure which action should be taken. Before we try to build an LR1 state machine, let's build an SLR1 state machine, where the S stands for simplified. We see that the process of building the state machine doesn't really look different from that of the LR0 machine. But as we build it, you will see how it looks different. The initial state looks a great deal like the one from the LR0 state machine. We begin with the special start symbol S, deriving dot, E, the expression, dollar, the end of file marker. The dot before the E means we need initial items for E. E derives dot E plus T, and E derives dot T. Since we've already accounted for an initial item for E, that second production does not require any additional items. However, E derives dot T means we need initial items for T. T derives dot F means I need initial items for F. And I've finished with the initial state. Now let's transition past E. And where before we had S derives dot E dollar, we now have in state 1 S derives E dot dollar. We have another production item where the dot is before an E. So as we move from 0 to 1, we also have E derives dot E plus T changing to E derives E dot plus T. In both of these two cases, the dot is before a terminal, so there are no additional items needed. Now let's deal with the transition past T, where before I had E derives dot T, I now have E derives T dot. Before I had T derives dot T times F, now I have T derives T dot times F. The first item is a final item. I've traversed through everything that I had there. However, in the second case, I still have two variables to traverse past. This is an example of a shift-reduce conflict, actually the one that we had seen earlier. Now we also have a transition past F. Before we had T derives dot F. On F, we traverse to state 3 where we have T derives F dot, another final state. From state 0, there is a transition on identifier. We go from state 0 where we have F derives dot identifier to state 4, F derives identifier dot, another final state. There is one remaining transition from the initial state we haven't covered. On open parenthesis, we go to state 6, where we had before f derives dot open parenthesis e close parenthesis. We now have f derive open parenthesis dot e close parenthesis. The dot before an e requires initial items for e, which in turn requires initial items for t and f. You can see at the bottom we have f derives dot open parenthesis e close parenthesis, which looks a lot like the item we have at the top, but they are not the same, nor do they represent the same thing. The one at the top means we've gotten past an open parenthesis. The second one at the bottom tells us that having gotten through one open parenthesis, we now have another. We have accounted for all of the transitions from the initial state. So let's go to state 1. On $, the end of file marker, s will go from s derives e dot dollar to state 12, s derives e dollar period. This tells us that this is the ultimate final state. On plus, we're going to go from state 1 to state 7. E derives e dot plus t. Once we traverse past the dot plus sign, becomes e derives plus dot t. I now need initial items for t, and in turn, initial items for f. State 2 again has a final item and a non-final item. For the non-final item, the transition is on asterisk. So we go from state 2 where we have t derives t dot times f to t derives t times dot f. We now need initial items for f. Given that all the items in state 6 are non-final, that's a large number of transitions that I need to deal with. I'll deal with the first one here. I had before e derives dot t, t derives dot t times f. In this case, to traverse past t in both cases, I will end up in state 2. To get past f, I will transition to state 3. So where before I had t derives dot f, I now in state 3 where it's t derives f dot. On identifier, I will go to state 4. So f derives dot id goes to state 4 where it's f derives id dot, another final state. On open parenthesis, I will go from state 6 back to itself. I've gone from f derives dot open parenthesis e close parenthesis to the item on the top, f derives open parenthesis dot e close parenthesis. Now you have to remember again, even though I'm coming back to the same state, I'm not going back to the same item. The dot has moved one place to the right. And now we still haven't dealt with the transition on e, so let's do that now. You'll notice here there are two items. F derives open parenthesis dot e close parenthesis leads to F derives open parenthesis e dot close parenthesis. The dot being before a terminal, there are no initial items, but I also have the item below it. E derives dot e plus t goes from state 6 to state 5 where it's e derives e dot plus t. Let's turn our attention now to state 5. On the transition for plus sign, we go from state 5 where we have e derives e dot plus t to state 7 where we have e derives e plus dot t. The dot moved one place to the right. We have seen this state before, transitioning to it from state 1. We still have another transition from state 5, this time on closed parenthesis. So we go from state 5 where we have f derives open paren e dot close parenthesis to f derives open parenthesis e close parenthesis dot, another final state. Now let's take a look at the transactions from state 7. On t, we will transition from state 7, where we have E derives E plus dot T, which will go to E derives E plus T dot. Similarly, T derives dot T times F will transition to T derives T dot times F. On F, we will go from state 7 to state 3, and we transition from T derives dot F in state 7 to T derives F dot in state 3. On identifier, we go from state 7 to state 4, from F derives dot identifier to F derives identifier dot. Our last transition from state 7 is on open parenthesis, where we will go from F derives dot open parenthesis E close parenthesis to F derives open parenthesis dot E close parenthesis. From state 9, we have 3 separate transitions. On F, we will go to state 10, from T derives T times dot F to T derives T times F dot. On open parenthesis, we will go to state 6, F derives dot open parenthesis E close parenthesis to F derives open parenthesis dot E close parenthesis. And an identifier will go to state 4, from F derives dot identifier to F derives identifier dot. And here you'll see our completed SLR1 state machine. Notice that we have a few states here, state 2, state 8, for example. That is a final state, but also a non-final state. This is what makes us different, and we will need to look at look-aheads to resolve the shift-reduce conflict.